Vector algebra, basic concepts. In this class, I will be discussing about the basic concepts of vector algebra. First of all, we should know what is scalar quantity, what is vector quantity. Then different types of vector, addition of vectors, subtraction of vectors, components of a vector, vector addition using components, multiplication of vector by a scalar, scalar product of two vectors, vector product of two vectors, then what is position vector. So these are the 10 important concepts about the vector algebra. So this will be very useful in physics particularly. Scalar and vector. Scalar is the property that can be described by magnitude only, whereas vector is by magnitude and direction. Examples for scalar quantity: distance, mass, temperature, speed, energy. So these quantities have only magnitude, whereas vector examples are force, velocity, displacement, acceleration, linear momentum, angular momentum. So these are all vector quantities. So the geometrical representation of vector is by an arrow mark. For example, an object moves from A to B means it is represented as AB vector. And this is a vector. The magnitude part is this much. Here you cannot find any arrow mark, so it's only a magnitude. So this is vector, this is magnitude of vector. In fact, this is represented by AB vector modulus, or you can call it AB. Now let us discuss about the different types of vectors. Different types in the vector. Equal vectors. Equal vectors. For example, let me have a vector A, direction as well as magnitude, both are same. So such vectors are called equal vectors. So it means vector A is equal to vector B. Collinear vector. Collinear vectors are those which act along the same line. For example, this is one vector, another vector. Okay. So this is vector A, this is vector B. They are collinear. It means the angle between these two vectors is either 0 degree or 180 degree. It means it can be like this also. In this case, this is 0 degree. Here it is 180 degree. They are collinear but opposite. Third one, parallel vectors. If two vectors are acting on the same direction, along the same line or on parallel lines, the angle between them is 0. So it can be like this. See that they are parallel, need not be equal. So vector A is parallel to vector B. Vector A is parallel to vector B. In that case, theta is equal to 0 degree. Anti-parallel vectors. Anti-parallel vectors. It means the two vectors A and B are said to be anti-parallel when they are in opposite direction. So one vector is in this direction, another vector is in this direction. So this is A vector, this is B vector. Okay. It means the angle between them is 180 degree. The angle is 180 degree. They are called anti-parallel vectors. Then unit vector. Fourth one, now this is fifth. Unit vector. So this unit vector is represented by cap. So A cap unit vector is equal to a vector when it is divided by its magnitude or simply A. So this should be called A cap, means unit vector. Okay. So from this formula you can call it a vector is nothing but the product of its magnitude and a cap. Then orthogonal vectors. Orthogonal unit of vectors. They are represented by I, J, K in the respective axis. For example, this is the origin O, this is x-axis, this is y-axis, this one is z-axis. So the unit vector is along x-axis, along y-axis, along z-axis, can be called I cap, J cap, K cap. For example, this is I, and here this is 2I, here it is 3J. I hope now you should be able to understand. And this is K, and this one is 2K cap. Okay. Next, addition of vectors. Addition of vectors. So there are two important laws. One is triangular law of addition method. Another method is parallelogram law of vectors. First, let us see the triangular method. Law. Triangular law of addition method. See, let me consider two vectors here. Vector A and vector B. Vector A, vector B. In fact, this part is called tail of the vector. This is head of the vector. And what about this? Tail of vector. This one, head of vector. Now, this A that has started from, of course this is origin, started from O, means it can be drawn as let us have O, this is A vector, let me call it OP is A vector. And what we are supposed to do is, you can move this B vector and fix the tail to the head of the A vector. So let us move, and I have fixed it here. So this is B vector. Okay. Now let me call it Q, and the resultant vector is addition of A and B. R vector is equal to vector A plus vector B. Okay. So this is called the triangle law of addition of vectors. Triangle law of addition of vectors. You should remember, for example, let me consider this as vector A, and I'm having another vector B. It is like this. Okay. So this is the head, this is tail, this is head, this is tail. Vector A, vector B. If I want to add these two vectors, what am I supposed to do? You have to simply fix this tail of B vector to the head of A vector without changing its angle. So bring it like this. Okay. Now you can connect this. Do you understand? So in fact, this is O, this is P, this is Q, and this is A vector, this is B vector, and therefore this is the resultant vector, vector A plus vector B. Do you understand this? In fact, being a displacement from O to P, P to Q, and you can reverse this direction, for example Q to O. Okay, so let me consider this O to P vector, that is represented by A vector, and PQ vector, that is represented by B vector. Okay, and QO, now it is returned if it is directed in this way, QO. Okay, now this is the reverse of R, is it not? Reverse of R vector. Okay, but we are interested in R vector only. You know very well, by adding OP vector plus PQ vector plus QO vector, you have reached the same starting point. So the net is zero displacement. You can bring this QO to the other side. Therefore, OP plus PQ is equal to minus QO. Am I right? What is this minus QO? This is nothing but that is positive OQ, is it not? Okay, so that is R. Therefore, this vector A plus vector B is equal to R vector. Okay, so this is known as the triangle law of addition of vectors. So do you understand this concept? Now let us explain about the magnitude of this resultant vector. Okay. Magnitude of resultant vector. So the magnitude and the angle of the resultant vector can be determined by following method. Let me draw OA vector. OA, and we have already taken this as B vector. Okay, so this is B. Now The resultant vector is R, is the resultant vector. And the angle between these two vectors can be interpreted by expanding or extrapolating this, and it meets a right angle. So let us call it N. So this is at right angle. So this is called the angle between the two vectors. So what is A? A is equal to a vector, that is OA. What is B vector? That is nothing but OB vector. And what is R vector? That is nothing but OB vector, AB vector. This is AB vector, this is OB vector. That is the resultant vector. And BN is perpendicular to AN. AN is expanded. Theta is angle between the two vectors. Vectors A and B. Right? And this angle is called alpha. Okay? And this angle is theta. Okay? Even for the angle we had to represent by arrow mark. So what is this alpha? It is the angle subtended by the resultant vector to vector A, right? Now let us consider this ANB, triangle ANB, right triangle ANB, okay, where BAN, angle BAN is theta, angle ANB is 90 degree. Therefore, AB is hypotenuse. Okay, and BN is opposite to the opposite side, opposite to the theta, so opposite side, and AN is adjacent side, is it not? Therefore, sin theta is equal to opposite by hypotenuse. Therefore, BN by, what is that? BN by AB. Do you understand this? BN by AB. Okay, and this AB is nothing but the magnitude of vector B, so you can call it BN by B. Okay, and this is sin theta. Therefore, BN is B sin theta. Do you understand this? So this can be called B sin theta. This is the vertical component. And what about AN? Similarly, cos theta is equal to an by the same AB, which is nothing but B. Therefore, an is equal to B cos theta. So you can mention this as B cos theta, right? Now, let us consider this OBN, okay? The bigger triangle, bigger right triangle, OBN. Let us consider triangle OBN, okay? That is this one, OBN. This is right angle, and OB is a hypotenuse, is it not? Therefore, OB squared is equal to ON squared plus BN squared according to Pythagoras theorem, right? Therefore, OB squared is equal to AN squared plus BN squared. Okay? Is it clear? And here, this A plus this ON is nothing but A plus, what is that? The magnitude of vector A plus B cos theta. So you can mention this as A plus B cos theta, right? And what about this OB? OB is nothing but R, is it not? So you can put R. So R squared. Instead of AN, you can put A plus B cos theta whole square. And plus, what about this? B sin theta. So, B sin theta, which is nothing but Bn, the whole square. Is it clear? Now, R squared is equal to A squared plus B squared cos squared theta, right? Plus 2AB cos theta. We can apply A plus B whole squared algebraic identity. So 2AB cos theta plus, what about this? B squared sin squared theta. Now we know already B squared cos theta plus B squared sin theta. B squared is constant here, that is common, so we can take outside the bracket. So R squared is equal to A squared plus 2AB cos theta plus this B squared of cos squared theta plus sin squared theta, right? We know already cos squared plus sin squared is equal to 1 according to trigonometric identities. Therefore, R squared is equal to A squared plus B squared plus 2AB cos theta. Therefore, R is equal to the whole square root of A squared plus B squared plus 2AB cos theta. Are you able to follow this? So this is the magnitude of the resultant of vector A and B. This is called the magnitude. Magnitude of the resultant of vector A and vector B, right? Now let us discuss about the direction of the resultant vector. Let me consider the same diagram here. Okay. What is tan alpha? Opposite by adjacent side in OBN. So b sin theta divided by this a plus b cos theta. Okay. Therefore, in triangle OBN, tan alpha is equal to Bn divided by OA plus AN. Therefore, tan alpha is equal to, what is Bn here? B sin theta. ON, A plus B cos theta. So, Bn, B sin theta divided by this OA, is it not? OA is nothing but A, magnitude of A plus B cos theta. Okay? Do you understand this? And alpha is tan inverse of this entire quantity, B sin theta divided by A plus B cos theta. So this is the direction of the resultant vector. Got it? The direction of the resultant vector. And what about the magnitude? That is R. Okay. So this R we have already seen the magnitude of A vector plus B vector. Magnitude is represented by the modulus. Okay. So this is also equal to R, that is equal to the square root of A squared plus B squared plus 2AB cos theta. Now let us discuss a small problem based on this. Two vectors, vector A and vector B. Vector A and vector B. They subtend an angle 60 degree. And it has got 5 units, and this one has got 7 units. Okay, 5 unit and 7 unit. Now find the magnitude of the resultant vector. So what is the magnitude of the resultant vector and direction also? Direction of R vector. Okay. Now we know already we had to draw like this. As I already mentioned, you had to push this vector to this side, is it not? So let us push this vector. So let me call it vector A and vector B. I am pushing this B vector here and fix on the tail like this. So this is vector A, this is vector B. So now we can draw a resultant vector, that is R. We already know R is equal to vector A plus vector B. Are you able to follow? Vector A plus vector B. So we have got already vector R magnitude is equal to, what is the formula? That is A squared plus B squared plus 2AB cos theta, right? So R modulus vector is equal to 5 squared plus 7 squared plus 2 into 5 into 7 into cos of 60 degree, because theta is equal to 60 degree, right? Therefore R is equal to 5 squared 25, 7 squared 49, and 5 2s are 10, 10 7 70 into cos 60 1 by 2, right? Therefore R is equal to 25 plus 49, 14 balance 1, 5 7, so 74 plus, this is 70 by 2, 35, so that is equal to 9, 10, 109 square units, 109 units. So R is equal to square root of 109. So 109 square root of 10.44 unit. So R is equal to 10.44 units, right? This is the magnitude. Okay. Now what is the next question asked? Alpha, angle between the two vectors. So this is the tan inverse of B sin theta divided by A plus B cos theta. Okay, so we have to work out this one. Tan alpha, right? Alpha is equal to tan inverse of, open the bracket, so B is 7, and what is sin 60 into sin 60, correct, divided by A 5 plus B cos theta, so 7 cos 60, close the bracket. Therefore alpha is equal to tan inverse of 7, what is sin 60, root 3, so 7 root 3 divided by, what about this, 5 plus 7 into, what is cos 60, 1 by 2. இது ஆமாம் sin 60 root 3 by 2, இது 1 by 2. இந்த 2 ரெண்டையும் கேன்சல் பண்ணலாம்ல, ரெசிப்ரோகேட் பண்ணலாம். அப்போ 7 root 3 divided by 5 plus 7 இல்லையா, ஸோ 12, 5 plus இந்த எடுத்துகிட்டு இது வந்து எவ்வளோ வருது, 7 root 3, ஓகே. இங்கே 5 plus 7 into cos 60 இல்லையா, ஸோ 5 plus 7 into cos 60 அப்படின்னாக்கா எவ்வளோ வரும், இங்கே ஏ தானே, ஏ வந்து 5 தானே இல்லையா. நீ இந்த cos 60 தகராறு வந்ததுன்னா பெஸ்ட்டு 30 60 போட்டிங்கன்னா ஈஸியாக ஆகிடும். இப்போது 30 டிகிரி 60 டிகிரி sin cos அப்படி போட்டுக்கிறோம். sin 30 1 by 2, cos 30 அதே மாதிரி cos 30 root 3 by 2. இது அப்படியே டயகனலாக நகர்த்திட்டு வந்தீங்கன்னா cos 60 is 1 by 2, இது root 3 by 2. இப்போ புரியுதா? ஸோ அப்போ இங்கே நம்ம tan ஆல்ஃபா தான் பார்த்துட்டு இருக்கோம். tan ஆல்ஃபா is equal to 7 into root 3 by 2. ஏன்? The formula says B sin theta divided by இங்கே 5 plus அப்படி இருக்கு, ஓகேவா, 7 into 1 by 2 தானே இல்லையா. இங்கே ப்ளஸ்ஸில் இருக்குது, அடிக்க முடியாது, நான் போட்டது தப்பு. ஏன்னா இங்கே 7 into இங்கே ப்ளஸ்ஸு, அதனால் தனித்தனியாக தான் போடணும். ஸோ 5 plus 7 by 2, கரெக்டாக, 7 into 1 by 2 7 by 2. So that is 7 into root 3 by 2 whole divided by, இப்போ வந்து 5 2s are 10, so 10 plus 7 whole divided by 2. இப்போ அடிக்கலாம். So 7 into root 3 by 2, அது whole divided by 2 போட்டு இங்கே 17 போட்டு இந்த 2 மேலே எடுத்துகிட்டு போகலாம். இப்போ புரியுதா? So 2 can be cancelled. So 7 root 3 divided by 17, இதுதான் tan alpha. ஓகேவா? இப்போ 7 root 3 அப்படின்னா tan alpha is equal to 7 into 1.732, அதான் root 3 divided by 17. So போடுவோம் 7 into 1.732 divided by 17 is equal to 0.713 வருது, 0.713. okay. So இப்போ ஆல்ஃபாங்கிறது tan inverse of 0.713. அது நம்ம trigonometric table போய் பார்த்தோம்னாக்கா தெரியும். இல்லாட்டா if you have got scientific calculator you can do this. So tan inverse of எடுத்து வந்திருக்கியா? It's okay, no problem. So 0.713 அப்படின்னா that is approximately 35 degree வரும். So இங்கே alpha. So ஆல்ஃபாவோட வேல்யூ கண்டுபிடிச்சிட்டோம். ஸோ மேக்னிடியூட் பார்த்துட்டோம், அதுக்கப்புறம் ஆல்ஃபா. ஸோ இதுதான் இங்கே உள்ள ஒரு கொஷின். அப்படியே ஆர்டராக அடுக்கி வச்சுக்கோ. ஸ்கூல் டைம் ஆயிடுச்சா? பண்ணி ஒரு கொஷின் கேட்டிருக்க, ஃபைண்ட் த வேல்யூ ஆஃப் lambda so that vector A is equal to 2i vector lambda j vector and plus k vector, அத k cap. அடுத்தது b is equal to அப்படின்னு போட்டிருக்கான். இப்போது இந்த ரெண்டுத்துக்கு இடையில் உள்ள வெக்டர் வந்து பர்பண்டிகுலர்னு சொல்லியிருக்கான். புரியுதா? ஸோ பர்பண்டிகுலர் parallel வெக்டர் அப்படின்றப்ப, அதாவது பர்பண்டிகுலர்னாக்கா 90 டிகிரி ரெண்டுத்துக்கும் இல்லையா? அதாவது திஸ் கம்ஸ் அண்டர் காம்பனன்ட்ஸ் ஆஃப் வெக்டர்ஸ் அப்படின்னு பேர். அந்த காம்பனன்ட்ஸ் ஆஃப் வெக்டரை பேஸ் பண்ணி தான் நம்ம எடுத்துகிட்டு போகிறோம். இப்போ vector A is equal to, it is represented by 2i cap plus 4j cap plus 5k cap அப்படின்னு ஒரு காம்பனண்ட் ஆஃப் வெக்டர்ஸாக கொடுத்துருக்காங்க. வெக்டர் B அப்படிங்கிறது i cap plus 3j cap plus 6k cap. ஓகேவா? இப்போது இந்த ரெண்டுத்துக்குமான ஒரு, அதாவது ஸ்கேலார் ப்ராடக்ட் இதுக்கு பார்த்தோம்னா வெக்டார் A வெக்டார் டாட் வெக்டார் பி இஸ் ஈக்குவல் டு என்ன சொல்லுவோம், ஏ பி காஸ் தீட்டா சொல்லுவோம். கரெக்டா? ஓகே. ஸோ இதில் ஏபி வெக்டார் இருக்குல்ல, இந்த இடத்துல இதுதான் லாஜிக்கு. என்ன கொடுத்துருக்காங்கன்னா ஏ டாட் பி. ஸோ ஏபி காஸ் தீட்டா, இவங்க வந்து தீட்டா இஸ் ஈக்குவல் டு 90 டிகிரின்னு கொடுத்துட்டாங்கன்னு வச்சுக்கோ. காஸ் 90 உனக்கு தெரியும் 0. அப்போ ஏ டாட் பி இஸ் ஈக்குவல் டு 0ன்னு ஆகிடும். அவ்வளோதான். சப்ஸ்டியூட் பண்ணிட்டு இந்த வேல்யூ கொடுக்கலனாக்கா அதை பேஸ் பண்ணி நம்ம கொண்டு வந்துடலாம். ஓகே, வில் கண்டினியூ இந்த ஈவினிங்.